Hey there, fellow makers and tech enthusiasts. Today we're diving into the world of DIY electronics with a project that's both fun and functional. Building your own battery management system with an Arduino. Batteries are everywhere, powering our gadgets and gizmos. But they need a watchful guardian, and that's where our BMS comes in. Ever had a battery die too quickly, or maybe overheat? A BMS is like a bodyguard for your batteries, making sure they charge safely, discharge efficiently, and live a long and healthy life. This project is perfect for beginners who want to learn about electronics and coding, and it's a great way to add some smarts to your next battery-powered project. So, are you ready to build your own battery guardian? Let's get started. Every superhero needs a team, and our battery management system is no different. Let's meet the key components. The Arduino board, the brains of the operation. This microcontroller will run the show, taking measurements and making decisions based on the data it receives. Think of it as the control center for our BMS. The INA-219. This clever chip is our current and voltage sensor. It keeps a close eye on how much juice is flowing in and out of the battery, like a watchful accountant for our power usage. The DS-18B20. Batteries can get a little too hot under pressure. This temperature sensor keeps tabs on the battery's heat levels, making sure things don't get too toasty. Safety first. The IRF-540. This is our muscle. The IRF-540 is a transistor that can control the flow of high currents, acting as a switch to connect or disconnect the battery from the load. The 16x2 display module. Everyone likes a good status update. This LCD screen will display important information about our battery, like voltage, current, and temperature. The SD card. Time to keep a log. We'll use an SD card to store data about our battery's performance over time, like a history book of its power cycles. Now that we've met our team, let's suit up and start building. First, we'll connect the INA-219 and DS-18B20 sensors to our Arduino board. These sensors will act as the eyes and ears of our BMS, providing crucial data about the battery's status. Next, we'll wire up the IRF-540 transistor to the Arduino. This transistor will act as a powerful switch controlled by the Arduino to regulate the flow of current to and from the battery. Now, let's connect our 16x2 display module. This will be our information hub, showing us real-time data about the battery's voltage, current, and temperature. Finally, we'll add the SD card module to the mix. This will store all the valuable data collected by our BMS, allowing us to track the battery's performance over time. With all the hardware in place, it's time to move on to the software side of things. With our hardware assembled, it's time to breathe life into our BMS with some code. We'll program the Arduino to constantly monitor the data coming from the INA-219 and DS-18B20 sensors. The Arduino will use this data to make smart decisions about the battery's safety and efficiency. For instance, if the battery's temperature gets too high, the Arduino can automatically disconnect it from the load to prevent damage. Meanwhile, our 16x2 display will show us all the important information in an easy-to-read format. We'll be able to see the battery's voltage, current, and temperature at a glance. And don't forget the SD card. All of this data is being logged for later analysis. We can use this information to track the battery's performance over time, identify any potential issues, and even optimize its lifespan. Our DIY battery management system is now up and running, keeping a watchful eye on our battery and ensuring its safe and efficient operation. From powering our latest gadgets to providing backup power during emergencies, the possibilities are endless.